All right. Welcome everyone to our third optional Python session of McMedHacks. Today we're going to talk about scientific programming with our instructor Saman Rahbar, and Luca and I will get a few things out of the way first. Perfect. Luca, would you like to start?
Yep. All right. Here we go. We're seeing a lot of your screen. Maybe you want to close your downloads.
Wait, what are you seeing right now?
All your tabs and what you most recently downloaded.
All right. Yes.
Yeah, that's better. So, welcome everyone. It's really nice to see so many people here. It's nice to see familiar faces as well. As Yujing said, this is the third optional introduction to our McMedHacks series. And we're going to have Saman as our instructor today, and we'll have more information about him on the following slides.
Oh, land acknowledgement first. As always, if you do not know what land you're on, you shall feel free to click on this link. Our virtual event is based in Montreal, Quebec, in Canada, which is a traditional territory of the Kanakahaka, and is on land which has long served as a site of meeting and exchange among Indigenous peoples, including the Haudenosaunee and Anishinaabe nations. We acknowledge and thank the diverse Indigenous peoples whose presence marks this territory on which peoples of the world now gather. We encourage you to learn and discuss about the history of the land on which you reside as well.
Now, we are going to be sending you guys a lot of information about our events. Most of that information comes through the email, and the email address that we'll be sending that with is medhacks2021, our founding year, @gmail.com. If you haven't been getting those emails, make sure to whitelist that email because it might be ending up in your spam otherwise.
Yes, and at this point, you might have already known, get into the habit that Miriam is the one that sends you these reminder emails. So before the session, she'll send you a reminder email of the details of our upcoming workshop, and after today, she'll send you a conclusion email, including again the Google Colab and the assignments made by mentors and so on. And yeah, we'll talk more about the assignments, the timelines on.
Yeah. So in terms of the rules, there aren't many. They all boil down to just be respectful towards both the people running this thing and your peers in this course. Don't unmute yourself unless it's a dedicated Q&A session. It is very encouraged to use your real name on Zoom. And you can ask questions in the Zoom chat and on the Discord, which I think a link for that has been shared in previous emails. We could share it again in the chat.
In terms of your real name, this actually it gets a bit important when we start to track attendance in the future. We'll talk more about it in the opening ceremony, which happens on the 11th, the Saturday. The way we track your attendance will be by email, by the email that you log in your Zoom with. So make sure that you log into your Zoom with the same email that you have registered for on the Google form that we initially sent out. Yes, and then feel free to discuss anything on the Discord channel as well as the Zoom chat over here.
Yep, so just to place today's session in the greater context of things, today we'll be talking about scientific programming with Python. As mentioned before, this is one of the optional programming refreshers that we offer. And we'll have the opening ceremony soon, next week, June 11th. So make sure you don't miss that. Yeah, and that's when the real program starts.
Yes, and then just Miriam's going to send you a Google Calendar very soon after we finish finalizing everything. But just so you know that you can go to our website and the program schedule is there. And that's when the workshops are going to happen. But usually on the Saturday, we also have invited speakers that you're very much encouraged to come listen to their unique topics as well. In terms of the time frame, it's always on 10:30. It's always at 10:30 a.m. to usually we want to limit our workshop and the talks to noon, so 12 p.m. But usually we go a little bit over time, and then including the Q&A session, safely we say it's 10:30 to 12:30. But the recording will be available online. You can always have access to it if you are in a rush to leave after noon. Oh, okay.
Yeah, all right.
Still
As
loading?
these pictures slowly render in, we're trying to introduce the anticipation. Well, these are our mentors. The mentors make sure that everything runs smoothly behind the scenes. They will be there to field your questions and pass them on to us if they can't answer them themselves. Today's mentors are Nadia, who's been introduced earlier, and Cesare. I'm sorry if I mispronounced that. If you'd like, you can unmute yourself and just say hello briefly.
I guess you're talking not to me, I guess.
Yeah, go ahead.
Okay. Yeah, so hi everyone. My name is Cesare, or you can also call me Ches. I'm an MSc student working with Professor Jackie Chung in the Department of Computer Science at McGill in NLP. And I'm actually working on biomedical NLP.
Thank you,
yeah.
Cesare. Sorry, I completely butchered.
No, don't worry about it. No one gets it right the first time.
Yeah. Nadia, please go ahead.
So hi everyone, my name is Nadia Blostein and I'm currently about to finish a master's at Dr. Millar Chakravarty's lab that specializes in the processing and analysis of neuroimaging data in order to examine neuroanatomy. Hi, welcome.
Perfect. Thank you so much. And thank you, Hossein, for recruiting our wonderful mentors. Announcements as usual. In the conclusion email, Mariam will send you the YouTube playlist that includes today's recording, the slide deck or presentation, Google Colab that Saman is going to talk about, and then obviously join our Discord channel. We'll probably share the link again later on in the chat. Perfect. Would you like to introduce our instructor, Luca?
Yeah, hold on 1 second. Let me pull up my notes here. Yeah, so today's speaker is Saman. And Saman is a senior applied AI scientist who has extensive industrial and academic experience working with biomedical data, signal processing, medical imaging, natural language processing, speech recognition, and e-commerce data analysis. He's currently working as a senior applied scientist working on enterprise-level automatic speech recognition systems, and has previously worked with a team of brain scientists on brain-computer interfaces. We're very happy to have you here today as our instructor. And with that, you can take it away.
Thank you so much, guys. Thanks, Luca. First of all, I want to thank everyone for including me in today's session. I highly appreciate that. And so can I share my screen? Can you guys see my screen?
Yes, we can.
Excellent. Okay, so in today's session, I'm going to talk about data science fundamentals and scientific computation with Python. I want to make everything simple to understand because I know that I have 90 minutes and I want to cover the fundamentals and the backbones that you guys might need before jumping into more advanced stuff, like, for example, image processing, medical imagery, and et cetera, et cetera. I believe having a good understanding of the tools that are available in basically industries would help you a lot to basically move faster with the knowledge or domain expertise that you want to gain in the next sessions. So today's agenda, let me actually just to see if I also see the chats.
We will cover the chat, and if there is something, we'll.
Oh, gotcha. Okay,
yes.
thanks, Farhat.
And also, it would be great if you make your browser full screen, so the screen is shared, so browser is not covering.
Is it? Oh,
Perfect.
gotcha. Yeah, for sure. Thank you so
Thank
much.
you.
Okay, so today's agenda, I'm going to talk about some of the basic concepts in Python. I'm going to basically initially had some stuff to refresh your memory about what variables are, etc., etc. I'm going to move faster. I'm going to skip some of those, because I'm aware that you guys have covered those. I'm going to talk about NumPy and pandas. We have a case study. I've included a case study. Because again, I believe that someone can learn better in terms of theory, like basically application of theories in practice, and get like a better sense of how he or she can apply different methodologies on that. I'm going to overview different data sets that are included in this Jupyter Notebook and case study, and I assume they would be shared with you guys. And of course, getting familiar with some pandas functionalities, and how to extract useful insights from data. Most importantly, I want to talk about how important it is as a scientist, engineer, or because I know you guys are coming from different fields, to have like a problem statement whenever you're given a task, an assignment, or whatever it is that you're doing, how to go about it, how to basically organize your Jupyter Notebook, your analysis, build assumptions, build case studies, and basically go about your solution and solve the problem statement. Let's go quickly over this stuff. I'm going to skip some of this. Again, here, this is just to refresh your memories. Like variables, you've already covered those. Variable in Python, as you already know, is like a package. It's like I like it to give it an analogy, like an Amazon package that gets shipped to your place, and then you open it and there's something in it. So that Amazon package could be that variable. The value would be like the contents inside that Amazon package. And again, you can give it any name. They have different different values. I'm gonna move fast and skip so we can get to different parts of it. But this is actually really important. I want to make sure you guys have a good understanding of different forms of variables. Because again, when you're talking about, as you move forward and you go to more advanced topics, most of the stuff that you're going to work on basically have libraries. And if you want to extend those libraries, because I know that you've also guys covered object-oriented, if you want to extend the class, knowing how to extend that class using a right data structure is essential and is really helpful. So for example, knowing how to extend a class in PyTorch using lists or tuple or set or dictionaries. So again, having a good understanding of this is really important. I'm going to go quickly over this. What is a list? Again, we've covered this one. So just like a brief introduction on those. A list, again, is an ordered and index collection of values that are changeable and allows duplicates. Here's an example of that. I'm not going to go deep into that. I just want you to pay attention to these different data types that a list can accept, because now we're going to compare this list with like NumPy array and the differences between these two. A list can accept any type of value. Again, going back to that analogy, like that Amazon package that gets shipped to your place, you open it and there are different values in it, right? One of them is this is string object. The other ones are just like integer values. Again, a string and floats. So you can see this is a vector of different types of values. And of course, a really common way to access different elements inside that list. Again, that's the same analogy, that Amazon package when you open it. How would you do that? Using this indexing. And again, it is really important to know that unlike some of the other programming languages like MATLAB, which engineers use a lot, Python starts with 0. So this is really important to know. So the indices start from 0 and go all the way up. So for example, this one, the index of this one is 0, 1, 2, 3, and so forth. In C++, C, and other programming languages, again, some of you might be familiar with, is kind of the same. But in other programming languages like MATLAB, it starts with 1. So that's the major difference that you want to know. And again, so it is easy to change entries of a list. You basically pick up, you say, okay, this is my list. I want to basically have access to this entry using the third index. And I want to change the value to 52. And you should be able to do that. It's easy to append a new value to a list. And again, append is a fancy name for addition. Pop is like basically getting rid of the specific elements. And you can actually give it a like index. So for example, get rid of that element at this index or value at this index. The same, another example. And tuples, again, is an ordered collection of value that are immutable and allows duplicates. Now, again, I want to make this session kind of interactive. I don't see the chats, but I want you guys to put your answers in the chat too. Again, we tend to use fancy names as scientists, engineers, and basically when you get to understand those concepts, you know that there's nothing fancy about them, just like basic concepts that are given fancy names. So who can tell me what immutable, or we can actually put your answer in the chat, what immutable and mutable entails? Do you guys have any idea? You can put it in the chat. Okay, I'll give you like 2 seconds and then. Okay, excellent. Yeah, already good answers. Okay, I can see Hossein and changeable, I guess. They can be changed. Excellent. So yes, as you mentioned, immutable means they cannot be changed, where mutable means they can be changed. We can add to it. We can basically get rid of elements. And that's the major difference, like one of the distinct differences between these two, tuples and sets. And it's really important to know. So here's an example of a tuple with different values in it, right? And again, it has all these characteristics. We can access different elements using the same method, basically using indices. Sets. A set is an unordered collection of values that are mutable and does not allow duplicates. So that's another major difference between these two that you should pay attention. And again, these are really important to know, because like, for example, you think about the application that you're going to work with. In terms of, for example, medical applications, you have data sets of different patients. You have data points of different patients in form of, it could be spreadsheets or whatever. You want to use, for example, lists to represent those values, but you don't want to allow duplicates for that specific, for basically different pieces of information that exist. So again, you might, at that time, I think, oh, I can use tuples or sets to do that. Whereas lists are more flexible. And we're going to talk about arrays too. And you see that's another beautiful data structure that you can use to do different tasks. Dictionaries, again, this is the last part, so I'm going to go quickly over it because I believe these are really important. Dictionaries, again, going back to the same analogy of that Amazon package that gets shipped to your place, and you open it and say, oh, there's some items in it. Let's look at it and see what exists inside. A variable is basically an Amazon package, right? But when you open it, different items that come out of it are values. So now if you have a scalar, like one specific value, for example, you purchase a balloon, that's the one value, right? If you have a list, then when you open that Amazon package, your variable, different items are in form of, for example, in a list, in a vector. For example, I bought a balloon, I bought, for example, a tablet, etc., etc. With dictionary, those items have keys assigned to them. They have labels, and that's the beauty of it. For example, you can open the same Amazon package, you can look inside and can say, oh, okay, so I have all these items. What is the item name? For example, pencil. What is the manufacturer? This manufacturer. What is the production? Basically, the year of production, 1985, for example. What is the next item in it? Item name, MacBook Pro. What is the production, the year of production, this, et cetera, et cetera. So with dictionaries, we have keys and values. And these are keys, these are values, and you can access different keys and values like that. And it's really flexible and nice to use. So now going to NumPy and Pandas. NumPy and Pandas are two most common tools that you can use to basically do scientific computation. And specifically NumPy, when you work with in the next coming sessions, we go and you dive deep into building neural networks, I would assume, doing different analysis on those. You want to represent data in a form that is flexible enough that would give you basically the capabilities of mathematical computation. For example, inner products, dot products, all the stuff that you learn in high school math. NumPy will allow you to do that. Pandas, again, is another tool, and we'll cover the differences between these two. So again, what is NumPy? NumPy stands for Numerical Python or Numeric Python. It provides fast mathematical computation and arrays and matrices. And that's, again, I want to highlight this. That's one of the beauty of NumPy arrays. It would allow you to do basically optimized computations. And again, if you're a computer engineer and you're really obsessed about compute time and space complexity, again, when you go back to it, there's some stuff that you can do with an NumPy array that would reduce that time complexity for you. So NumPy provides the essential multidimensional array-oriented computing functionalities designed for high-level mathematical functions and scientific computation. So here I have because someone might actually in the audience might say, oh, okay, so what is the difference between an array and a list? Because I don't understand it quite a bit. So these are the differences between these two, lists and arrays. As you saw above, lists can contain elements of different data types, right? We had at the top here, if you saw, we had Dan, we had 2, 3, 4, we have Python, string, and 2.71. And I see one question from Pranab. Array here is NumPy array. Well, yes, basically NumPy is a module that would allow us to do basically use this type of data structure array. So NumPy is one that would allow us to build arrays and work with it. And I'll show you how we can import it and how we can use it. But first, let's just see the concept. Look at the concept. So again, with lists, we have different values, different types. But with arrays, again, let's go back to the comparison between the two. It contains elements of same data types. And you'll see why. I'll talk about why that's the case when we get to that point, that section. And for lists, explicitly importing module is not required to declare a list. So again, as you saw at the top, basically all we had was just like brackets, and we had different values inside that, right? Again, the same idea with that Amazon package. Again, the same analogy. And with arrays, you need to import the module explicitly to declare an array. And again, here we use NumPy to do that. So a list cannot handle arithmetic operations, sort of. I mean, you can make it work, but in general, they're not easy to do. And you have to be careful about, like, for example, the error that you might get, basically the problems that might occur when you sum different values, et cetera, in a list. But arrays are easier to handle arithmetic operations. A list can be nested inside another list, must contain arrays, must contain all elements of the same size. And again, you see why that's the case. For lists, let me actually go to the main points because there are so many, and I'll just highlight the main points that you guys need. So again, we can have easy modifications like addition, deletion, and update of data elements. For arrays, it can be a little bit difficult to modify an array since addition, deletion, and update operation is performed on a single element at a time. And again, I'll show you what I mean by that. And of course, the memory. In terms of memory and all that kind of stuff, for easy addition of elements, large memory storage is required when you're using a list. But when you're using arrays, in comparison to the list, it is more compact in memory size. So again, if you're working with, for example, building large neural networks and want to store a huge, basically, here I would say container of values, a bucket of values, in order to basically do operations like, for example, convolution, et cetera. Again, don't worry about the names, the fancy names that the scientists we give to them. They're pretty straightforward, and we get to learn those. But if you want to do those, then array will give you functionalities to basically do that. So now let's see how we can declare NumPy array and basically work with it. There are several ways to create an array in NumPy, like np.array, np.zeros, np.ones, etc. For each one of them, like we have some flexibility, and I'll talk about like each one of them, what they do. But in general, again, we use NumPy to initialize or declare or explicitly mention that, hey, we want to have an array. We want to build an array. And here, as you can see, we import NumPy as NP. And again, just like quotation, like a quick reference that since we like data scientists or engineers are kind of lazy, they want to give aliases to different modules, so it's shorter and easier to use. In Python, when you want to import a module, you use import keyword, and then you use the specific library that you want to use. Here, in this case, we use NumPy, and we give it like an alias, another name. It's shorter, better to use. And let's see the difference between this and a list. At the first glance, you look at it and say, oh, this looks like a list with some, modifications to it, some more complexity. And you're right. So this looks like a list, but if you pay attention, as we discussed, the data types, different types of values inside this array are the same. Here, we have explicitly mentioned that these 1, 2, 3, you can observe, you can look and say, oh, this should be integer, but no, actually they're float 32. So we have explicitly mentioned that the type of these 3 should be float 32. So, and that's how we can declare that. Simple line of code. NumPy.array 1, 2, 3, and the data type is basically each one of these is float 32. And this is a vector, and I'll talk about the differences between a vector and a matrix, and I can identify those in NumPy because those are really important because we want to do dot product, inner product, and then basically different operations and mathematical operations on NumPys. So we'll talk about those. The beauty of it is like, again, Python has different built-in functionalities. For example, one of them is type, and if you apply it on top of this NumPy array, we just like say, hey, this is a NumPy array. So that's what it returns. And you can also use different basically the functions on top of it to perform different operations. Like, for example, we have shape. So we initialize this NumPy array, and shape basically returns the shape of that array, the size of that array. And usually what it entails, the number of rows, the number of columns. If it's a vector, so it would just say, hey, this is a vector. Okay, see, another question. Can you please tell what is the reason of giving data types as float 32 instead of float 64 of integer? Well, that's a really good question. And it goes back to the computation and the compute time. For float, it goes back to basically the way that each number is represented in the memory. And float 32 basically is less memory intensive, whereas float 64 is more memory basically intensive, and depends on the application of, for example, the number of values that you want to basically present. You use either float 32, float 64. Usually people use float 32, but again, there's no strict requirements. We can use either of those. This is just an example. Okay, so now we talked about shape function that you can apply on top of A. And as you saw, we had this. If we apply shape on top of A dot shape, you should return the size of that array. And as you can see, this is the result: 3, comma, nothing, and inside this parenthesis. So what does it show? What does it say? It is saying that we have a vector of 3 elements and we don't have the second dimension. That's all it's saying. Usually the first one entails the number of rows, the second one entails the number of columns. In this case, as you saw, it's something like a list with 3 elements inside it. And once we basically get the dimension, it's just basically saying, hey, we have 3 elements inside that array. It's a vector. We don't have the second dimension. Here's another example. If you pay attention, the numbers are not sorted. So we have 2 and then 1 and then 4. Again, NumPy would give you some nice functionalities that you can sort different values inside different basically arrays. And again, this is really important because, for example, imagine you have an image and you want to present that in terms of pixels and basic intensities, and you want to sort them based on highest and lowest. Again, you can store the values inside these NumPy arrays and sort them like this. Just to give you an example, an idea how it can work in different applications. And once you do that, you have a sorted array, and you can see they have 1, 2, 4, ascending to basically descending to ascending. So now again, going back to before going there, just to see if you guys have any intuition, does anyone know what is a rank 2 array entails? And also rank 1 array. Anyone, you can put it in the chat. I'll give you a second to think about it. Actually 5 seconds, sorry. Okay, so we have ranked 1 array and ranked 2 arrays. And again, these are fancy names that we give it. We give to different terms. But a ranked 1 array is just basically a vector, right? So we have a rank 1 array, a vector. Example of that you saw here. Different elements inside the array. We have a rank 2 array. So what is a rank 2 array now? We have values across x-axis and y-axis, right? So we have a rank 2 array. What do we call this? Values matrix, exactly. Good point. So we have a matrix now. And the beauty of it is like that fast in one single line of code, we can create a matrix. And that's how we can represent it. So we have NumPy, the same thing, NumPy dot array. And if you pay attention, we have 2 square brackets. Entailing that, meaning that we have a rank 2 array. And if you print that, you will see this matrix, number of rows, number of columns. We have 2 rows and 3 columns, right? Basically a way for us to present a matrix. Again, another application of that when you want to represent images, right? Images, what are images? What are basically images in like grayscale, only one scale, a matrix, right? A matrix of pixel intensities. So we can actually present that in this form with rows and columns. And another beautiful function that you can apply on top of this is ndim, n dimension. And what it returns the number of dimensions that this matrix has, or this array has. And in this case, it has 2 dimensions. So now let's go back to this NumPy advanced. We have different functionalities that would actually give you easier and faster access to create arrays or matrices. So NumPy advanced, again, as the name tells, would create matrices or vectors of 1. So here you can specify that, hey, I want a matrix. How can I know it's a matrix? Well, I gave it X and Y axis, 3 and 4, 2 dimension. And I want the data types to be integer 16. Again, someone might say, oh, why not integer 32? Why not integer 64? Again, the same reason. And there's no strict requirement. It's just like based on your compute time and whatever you want to represent. And so we have this array, and this is the way that it's represented, right? 1, 2, 3 rows, 4 columns, and they're all of type integer 16. And I see someone is saying, do rank and dimension are the same? Yes, in basically loose terms. There's more terminology into that, but you can think about it that way. And then we have NumPy array range. Again, this is another beautiful functionality which you might want to use a lot. And what it does, if you give it 2 boundaries, like starting point and basically endpoint, it would say, okay, give me 5 data points within this basically limits, the starting point and the end point. And it does that for you. Oops, I have to, and that's what happens to your Colab if you don't run stuff. Okay, there's another one, linear space. And again, it creates data points between 2 values, 2 boundaries, linearly spaced. So again, most of the names are also self-explanatory. Again, here as an example, we see between 0 and 5 divided by 2. I want to get 6 data points, and I wanted them to be evenly spaced. That's how I do it. If I change this to 10, let's see if and again, make sure you have imported the libraries before you use them, because if you don't, you get an error. So again, I make sure this is imported, NumPy as NP, and then I come here and I run this example. Here we go. So we get 6 data points between these 0 and 10. And then we have another one. So we have so many different functionalities with NumPy, and I'm not going to cover all of them, but once you get the idea of NumPy, the concept, you can read the documentation. There's like a comprehensive documentation on NumPy, and most of them are self-explanatory with lots of examples. I've added actually a reference in this notebook to that too here, that you can actually check and see how they work. Just to be mindful of time. Okay, so now array indexing, another important point and another important part. So we can create matrices, we can create vectors. And now how can we access different elements inside those? So again, with lists, it was easy, right? Because we wanted to access only one item inside that package. Again, that Amazon package delivery. We just wanted to say, oh, the first item that was put in that package. So we can go and just grab it and look at it. With basically matrices. Now, things get a little bit tricky, but again, that's the same concept. We want to see, okay, get the element of the first row and the first column, right? Because now we have a matrix. We have columns and rows. Get the second of basically second elements inside basically the first row and the second column, right? The last row and the last column, because now we're dealing with columns and rows. 2-dimension. So how do we do that? Of course, we were familiar with this, right? Before we had a list. So ignore this part. Before, if we had a list, we would do something like this because we wanted to access only one element. Now we have 2 dimensions, so we extend that. How do we extend that? Like this. And what does it say? Let's check what it entails. So the first one is the number, basically the location inside the rows and columns, right? So the first one was rows. The second one was columns. And what we're really trying to say is, hey, give me, this is basically the first row and the second row. And what is this one? The second column and the third column. And again, be mindful that Python starts from zero index. So what we see here, we have 1, 2, 3, right? We have 3 rows, 1, 2, 3, 4 columns. What do we have? When we do this, we say, give me the first, the second row and the third row and the second column and the third column. So that's what it returns, 2, 3, 6, 7. And again, once you play around with it, once you try to print your own NumPy arrays, it would make more sense. So the more you play around with it, you see these examples, the more it would make sense to you. So now going back to the array math, like mathematical operations or functions that we can have on arrays. And that's one of the example beauty of NumPy arrays. It would allow you to do mathematical operations really fast. And we'll see examples of that. So for example, here we have X and Y. We create X with these 2 elements. And again, please put in the chat, what is this array like rank 1, rank 2? Who can tell me? Just we can push your ideas in the chat. Rank 2, excellent. Yes. So we have these 2 rank 2 arrays. How do I know? We have, first of all, we have 2 square brackets, right? And what I can actually, the way I can simulate this, I can say, oh, this is row number 1, row number 2, column number 1, column number 2, right? So if I print them, I will get something like this, 1, 2, 3, 4. But let's see what's going on here. We have an X, we have an X, which is an array. We have Y, which is another array. And look at the basically the number of elements inside these 2. They're the same. So we have, again, 2 rows, 2 columns, 2 rows, 2 columns, rank 2 arrays. And we want to do element-wise sum. We want to sum each value, for example, value at row 1, column 1, added to value of row 2, column 2. I'm sorry, row 1, column 1 of the other matrix. So element-wise sum. So let's see how it works. When we create an array like this, and when we add them, NumPy array does it for us, and it does the element-wise sum. So what we get, we basically summing these ones. 5 plus 1, 6. 6 plus 2, 8. 3 plus 7, 10. 4 plus 8, 12. And we build this. So we have elements-wise sum. Another way to do that, we have numpy.add, which is basically the same thing, does the same thing. So it would return the same matrix. If we do this, yeah. So element-wise difference both produce the array. So basically, we saw that we saw this with summation. Now we can do this with any other operations, like for example, difference or division or multiplication. But here's an important point, a really important point that I want to mention. This asterisk here, it's Intel's element-wise product. And I see this is what even many senior data scientists sometimes fall into, like the problem that they have in their computations, they get lost. And some of them say, instead of like inner products, they do this element-wise product, element-wise multiplication. And that's an important point to remember. This asterisk does the element-wise product. Unlike MATLAB, unlike any other programming language that this might entail like the dot product, this is element-wise product in Python. So again, another way to present that is multiply. Element-wise division, the same concept. And that's just, again, the beauty of NumPy arrays. You can do so many different things with it. You can just like apply different operations on top of it, and it does it for you automatically in a really nice way. Square root, for example, different values, we have the same. And again, I mentioned this note here because this is really important. And I've seen many senior data scientists falling into that trap. And that's pretty sad, but that's what's happening. So be mindful of dot product and element-wise, I'm sorry, the basically element-wise product or multiplication. So I mentioned an example here, how we can actually do the inner product now. So, or dot product. You saw that we have X and Y. Again, we recreate them again using NumPy arrays. We have two other NumPy arrays, V and W. And again, who can tell me, put in the chat, what is the rank of this? What is the rank of this one? What is the rank of these two? What is the rank of X, Y? What is the rank of V and W? It's really good to just intuitively, by looking at the array, say, oh, this is rank 2, this is rank 1. And if you want to do the inner product of vectors, you do this. So again, it's really important to understand the inner product and the multiplication. If you want to do a dot product, you can explicitly mention V, do the dot product with W. Or there's another way to do that, NumPy the dot V and W, dot product of these two. There's another way to do that, which is kind of less common, but it's like fancier. It's like V at W, which actually does the dot product for you. So now let's move a little bit faster. Actually, we have lots of time. So let's actually talk about transpose. As you know, it's really common for matrices. Once we create matrices to do transposition, and we transpose the matrix. And that's often what you do when, again, just have all this stuff on your mind when you go to your next sessions to do, data manipulation with images and all that kind of stuff, to build new data points, stuff like that. You create these matrices with different values, right? Those values could be pixel intensities or whatever you want to call it. And for example, you want to rotate the matrix for the purpose of, for example, data augmentation. Again, you don't need to know about this stuff. For example, creating new data points. So by shifting or rotating the matrix, you can have, different sets of values. So here is an example of that. We have X, right? And X is the array that we built here at the top, 1, 2, 3, 4. We transpose that, matrix transposition, and that's what we get. And all you need to do is this, X dot T. Again, here's another comprehensive documentation. You can look at different functions. There's so many examples of that nature in there. Now we go to a beautiful concept in arrays, which is broadcasting. And I'll tell you what it is. Broadcasting is a beautiful concept. It actually allows you to basically do fast computations and basically allows you to get rid of for loops. And let's see how it works in practice. Again, so broadcasting is a powerful mechanism that allows NumPy to work with arrays of different shapes when performing arithmetic operations, mathematical operations. Frequently, we have a smaller array and a larger array, and we want to use the smaller array multiple times to perform some operations on the larger one. Let's look at some of the examples here. For example, we have this NumPy array, and we've called it again X. What is the rank of this? You guys are all pros now. By looking at it, so this is rank 2, right? We have excellent. And what is the rank of this one? Rank 1, right? We have a vector of different values. And what do we want to do? We want to add the vector v, which is of rank 1, to each row of the matrix X. And we want to store the results in matrix Y. So again, this is rank 1, this is rank 2. The ranks is different. So we want to do something to be able to do that, to add these basically values to each element of X, different rows of X. So there's, again, this function that you can use in NumPy. It is called empty like. It creates an empty array matrix with the same shape as X. So X, for example, this has this shape. And again, who can tell me what is the shape of this? Just by looking at it. If I apply X.shape, what would I get? And remember, shape would give me the number of rows, number of columns, right? Dimension. 1, 2, 3, 4. Excellent. 4 rows, 3 columns. So that would create a matrix with that shape. And look what I have to do to actually add this V of shape, this shape. And again, what is the shape of this? Okay, who can tell me what is the shape of this one? It would be interesting to know your guys' opinion now. Should we cover those? So this is, again, a vector, right? So shape would give me or return number of rows and columns. Do we have any columns? Someone is saying 1, comma. Is that true? We can try. Let's see what it will return. So if I apply v.shape, we get 3, comma, right? Because we have 3 elements inside that vector. But the second dimension is missing because there's no second dimension. We have only 1 dimension. It's a vector. So in order to add this to each element of this, to each row of this matrix, I have to write a for loop, which is kind of exhausting and it's ugly and gross. So you usually want to avoid for loops. It's kind of, computation heavy. You have to loop through different elements, and here 4 is like different rows, right? I go through different rows and I say, okay, for each row, add these values to individual basically values inside them, the rows of the first one. Sorry. And usually you want to avoid that. There's a hacky way to do it, but is it good? Let's check it out. What I can do, I can use numpy.tile, and what it does is just say, okay, stack 4 copies of this. So now I can have 4 copies of the same row. Then basically the shape of this array would be similar to the shape of this array. Then I can do that instead of using a for loop. But again, that's a hacky way. It can get ugly. I don't want to do that either. And basically, if I do this, then I can basically skip the for loop and add them together. But NumPy broadcasting actually allows me to do it without any for loop, and that's the beauty of it. So I don't need to use any for loop. I have X again with the original shape. I have V with the original shape. when I say x plus y, NumPy would automatically in a smart way say, oh, okay, so the shape of this is this, the shape of that is that. They don't match. What would I do? I'm going to broadcast it. I'm going to just deal with it. So it does deal with the dimension, and it gives you the final results. The result that you would expect, basically, when you were doing the for loop, or like NumPy.tile. Well, it compares them. It basically, again, it uses the default built-in functions, right? It gets the shape of x. It gets the shape of v. It knows that when you use the summation x plus v, the shape should match. So it says, okay, I'm going to increase the shape of v to make it compatible with the shape of x, and then sum them. That's how it deals with this summation. That's how NumPy knows the dimension. Basically, it's after all, it's a NumPy array. So the built-in functions are the same. We have shapes, so it uses NumPy.shape to get the shape of this, the shape of that, compares them, and does the job. So that's the beauty of NumPy. And I mentioned here how the broadcasting basically broadcasting happens. If the arrays do not have the same rank shape, then we do the broadcasting, and also different points that you can go through. So now we're going to talk about pandas. So far, we talked about NumPy and how beautiful they are, how fast they can get, how they can actually deal with matrix basic creation, broadcasting, multiplication, mathematical operations, and so forth. So what we do here, we are now going to cover pandas, and pandas again is another way, another tool that would allow you to read data and usually represented in the form of like a spreadsheet. You guys, everyone have seen like Excel spreadsheets and like the columns and rows that you've seen. So pandas would allow you to quickly create that. So again, similar to NumPy, pandas is one of the most widely used Python libraries in data science. Pandas provides in-memory 2D table object called data frame. It is like a spreadsheet with column names and row labels. We can import and use it using import pandas at PD. So again, as data scientists, as software engineers, as engineers in general, we tend to be a little bit lazy. Scientists a little bit less, but we want to give alias to different modules that we import. So again, import pandas. In order to make it shorter for us, we use PD. We give it an alias. So again, if you see different aliases with different names, don't panic. They're all the same. This is pretty standard though. Whenever you use pandas, it's pretty standard to give it an alias as PD, NumPy, NP. So now let's create a data frame and see how it works in practice. And of course, we can get to our exciting use case. So we have this example. We're creating this pandas data frame. Let's see how we're utilizing the data structure that we learned at the top. Do you remember I told you that analogy that I gave you? The Amazon package gets shipped to your place. You open it. If you have used dictionaries, you have labels, key and values. We use the same concept here. So in order to use Panda data frame, we use dictionaries. And let's see how we use them. First of all, this is how we use it, pd.data frame. We try to access this object. And let me know if my voice is actually too loud, because I feel my mic is actually lost again.
No, it's great. Thank you. Go ahead.
Oh, thank you, Farad. Okay. And then basically we have these keys. For example, we have species as keys. Do you remember? I told you whenever we want to initialize a dictionary, we have keys and values. And look how we have used a list as a value for this specific key. So we have species, but for values, we have burr, and marsupial. I don't know what this is. If I'm pronouncing it wrong, I apologize. But again, we have another key, population. And again, we have sets of values for this key. 1846, 64, 22,000, 80,000. And we give it an index. So we can also manually give it an index. If we don't use this, the index would be 0, 1, 2. If we set an index, the index would change to the specific keys that we use. So when we do that, we get this beautiful table, nice table, as you would see in a spreadsheet, Excel spreadsheet. And here we have species and population as the keys. Do you remember? These were the keys and these were the values. So values for species, marsupial, population, values from population, and the index. That's how we create this beautiful, easy to use data frame. Now, before we dive deeper into this using our use case, I'm going to go and have a brief intro on visualization. I'm not going to make it fancy. There are so many fancy things you can do with visualization and specifically Matplotlib and Seaborn. I'm going to talk about the tools. We can use them, and I'll refer you to the docs for further your further analysis. So Matplotlib, two most common visualization tools that you guys would use is one of them is Matplotlib, the other one is Seaborn. And I don't know if you guys remember the photograph of like one of the major black holes that was captured by one of the physicists. She was using Matplotlib. So again, this is how common this library can get. And it's really easy to use. The beauty of it is, as long as you can represent the data in form of NumPy arrays or lists, you can use them to create your visualization in a single line of code. And that's the beauty of it. So again, Matplotlib is an open source drawing library that supports various drawing types. You can generate plots, histograms, bar charts, and other type of charts with just a few lines, of course. And again, visualization topic itself is like a vast, comprehensive topic. I'm not going to get into that. These are different types of plots, and knowing different types is also basically beneficial. I'll give you some links. I've mentioned some links in this basic Jupyter notebook where they can study and learn more about different types of visualization. I brought some examples here to show you, but yeah, we can read further about them. So it is often used in web application servers, shells, and Python scripts. So again, in one of those interactive, non-interactive, basically web applications that basically you would see graphs and different visualizations. If they're written in Python, most probably like they're written, they've used Matplotlib or Seaborn to accomplish that. So again, this is how we import the library. And just to make sure you guys know this, all these libraries should be installed using pip. You can use the pip install to install those packages. I assume you guys covered those. So make sure you guys have installed these packages when you're using it. So again, we import matplotlib.pyplot as PLT. So that's another fancy alias we give it. It's shorter because we don't want to use this long name, and it's pretty standard. Let's see how we can create two lists and visualize some data points. So again, this is something pretty simple, right? X is a list of values. 1, 2, 3, 4, 5, 6, 7, 8. Y, 2, 4, 6, 8, 10, 12, 14, 16. And we want to just like see the interaction between those. Again, someone might think correlation plots or line plots, which here we have a line plot, right? Relationship between these two, X and Y. Is it increasing? Is it decreasing? Is it a positive correlation? Is it a negative correlation? So you can all do that with the Matplotlib as long as you can present the data in this right format. And then we can use plt.plots, give it x-axis, y-axis, and boom, there you have it. So again, similar to Python, like MATLAB, C++ to some extent to accomplish this. And again, you can use the title, plt.title, plt.xlabel, which sets this x label, it sets this y label. And of course, you can save the graph as well. It saves it on your disk, on your local computer, or like basically the directory that you're running this Jupyter notebook from. And you can give it any name. Example.png, for example, in my case, is the name. Now let's see how we can use it like a bar plots. So again, that was a line plots. By default, when you use plot function, you give it x and y, just like goes with like relationship between these 2 points. This creates this line plot for you. When you explicitly mention bar and give it x and y, it creates this bar plot for you. And again, the same concept. We have scatter plots. And again, scatter plots, if you want to, they all have their functionalities. And again, in terms of application, one of the good skills that a scientist should have, I believe, is how to use the right visualization. So these are really important. For example, you want to have a correlation plot, but what you're going to do is like using a bar plot. It might work, but it's gross. So you don't want to do that. You want to avoid it. So again, a really good skill a scientist should have, an engineer should have is, hey, where and how should I use the plots in a beautiful and efficient way? So scatter plot, use scatter, and we can have by pie chart. Please don't use pie chart. I hate pie charts. It's just so vague, but this is how you can actually use pie charts. You can plt pi x, and if you remember, x had this list and with values in it, right? So but all we're doing is just like in terms of pie chart, what are these ones are. And again, I created this label. You can actually give it label too. For example, the label can have multiple values. So this is a string, I call that Sam. The other one's like 2, 3, 4, 5, 6, so forth. And you can give it a title. Seaborn. Seaborn is an amazing visualization library for a statistical graphical graphics plotting in Python. It provides beautiful defaults, styles, and color plates. Again, it basically sits on top of the Jupyter Matplotlib. And for example, here using NumPy arrays, we want to kind of build this histogram or a distribution plot. What we do here, as you can see, we import Seaborn and we give it an alias. Again, another alias, SNS, because it's shorter. We want to build a normal distribution with like a population of size 100. So that's what it entails. And basically RS, we give it a random state. This is like a random seed. Basically say, okay, just give it a random state and produce a population of size 100 and simulate this normal distribution. And now have a distribution plot of that. And that's what we get. It's beautiful plots, distribution plots. And this is like a density. And you can give it like, this is the number of beans. Basically Seaborn, and again, on its own is like a huge topic. Visualization on its own is like a comprehensive topic. I'll give you like, I've mentioned some references in this notes, but they can actually look and read further about them. But now let's dive into the case study. Some of the main points. So what we're going to cover still is about the pandas. So we talked about NumPy, but pandas in practice is beautiful and it's easy to use. You can merge, join tables, etc., etc. I'll talk about what I mean by that. But before that, let's see how we can structure a project. Again, as a scientist, it's a really, I believe it's a good skill to know how to organize your project, how to go about solving a problem with the problem statement in your mind, the objective, and your possible solution and hypothesis. And usually you have a context, you have an objective, you have data set that you're going to work on. You have sets of tools that would allow you to do the analysis. And of course, you build your assumption and you go about them. So again, great skill to have. And it doesn't matter what the problem statement is, what the case study is. What matters is how you go about it. So again, it can be about, for example, medical data analysis, information about different patients, how you build the context, how you build the objective, what assumptions you have, what prior assumptions you have, what hypothesis you make, how you go about it, and use different tools to accomplish the basic objective, reach for conclusion. So here, it's pretty simple. The movie rating system that field buffs know today has been around for over 50 years. Over the years, the culture standards and norms have changed, and so have movie ratings. However, even today, the process of rating a film remains a closely guarded industry secret. So what is the objective? The objective, I think I'm sticking it. Okay. So MovieLinks is a company in the internet and entertainment domain that has an online database information related to films, television series, online streaming content, including cast, production crew, trivia, ratings, and fan and critical reviews. You've been hired as a data scientist for the company. You've been provided with the following 3 data sets. So you have 3 data sets. And again, the data set could be medical images or not even images. For example, speech images, like corpus of different languages. Again, don't worry about the terminology that I use, like data points related to, for example, spoken languages. So you've been provided the following 3 data sets, asked to carry out a detailed analysis of the data and come up with some meaningful insight, which will help the company to address the users in a better way. So we have these 3 data sets, and you can see they're all in CSV file: movie.csv, user.csv, rating.csv. So now we want to look at them. We want to load the CSV files and see how we can use them. So let's see how that can be done. You got familiar with NumPy. Now let's see how pandas work. So we import pandas as PD. Let's see how we can read the data set. We want to read the data set by using read CSV from pandas package. Once you import this library, pandas as PD, all you need to do to read the CSV file is this single line of code, assuming that movie.csv exists on your local computer in the same directory. And you can see this is my current directory. I have these 3 data sets, and I can load them and read the CSV file, and that's it. That's all you need to do. So if I run it, I've loaded the data set. Now let's see how I can look at it. So the initial step to understand a data set: observe the first rows of the data set to check whether the data set has been loaded properly or not. So that's the first step. You want to make sure the data set, the CSV files are loaded. You want to see how they look like. You want to see like a general understanding of what you're looking at. So user data set. And again, we gave it different names. So again, these are buckets. These are like those Amazon packages that get shipped to your place, right? The same analogy, but now they have the loaded CSV file inside them. So I can call them and I can see all the data points in form of that table inside them. So again, one of them is user. Let's see what like the number of columns and rows and the column names that I have. So I have user.head, and let's see, I have all these columns. You can see that PD.read CSV converts my basically CSV file to this beautiful format with rows and columns. So we have user ID, age, gender, occupation, zip code. These are our columns, and these are the rows. And this is the function head. Again, this is like a default function that Pandas has. When you read the CSV and apply it on top of that, it gives you the top 5 rows. If you don't use this, if you don't use head and run this user, it would give you all the rows. So I don't run it because I have many rows inside that data set. But if you run it, you would, if you have like 10,000 rows, it would show all the 10,000 rows. It would load all the 10,000 rows. So we look at it and say, okay, so the data set has been loaded properly. The user column contains, for example, demographic information. I can look at it and say, oh, this is a string, like this is of type string and has binary values, right? Male and female. I mean, not binary, but this is string values, and it refers to the gender, male and female. We can also
Sorry
observe.
for interrupting you. Would it be possible to share the CSV file as well with the participant?
Oh yeah, absolutely, for sure. I'll do that. So you guys would be able to get the CSV files as well, all the CSV files. Yeah.
Is it possible to share it right now so people can follow along?
Oh, let me see if I can actually share that using the. Oh yeah, I think I can do that right now. Let me. Can I put it through the chat? Let me actually do this here. Connect to Google Drive.
I also sent you a link for a Google Drive folder. You can put it there and I can share that folder with everyone.
Yeah, for sure. I put that in the email, Farhad, the one that's basically had this Jupyter notebook. Can you find that? Because it seems that I cannot.
Okay, I'll take care of it. Thank you.
Yeah. It seems that so it's inside that email that I sent. You might be able to actually quickly get that. And let me, because it seems it's asking me for credentials here, but it doesn't log in. That's kind of strange. Let me Dropbox. Connect to Google Drive. Connect using my. Oh, I don't know why it's giving me like bad credential error, Farhad. It seems that I can't log in, but it's inside that email. You should be able to find it. I can email this quickly to you.
I have it right now.
Oh,
I'll share
good.
it right away.
Oh, thank you. Thank you so much. Okay, let's go back to the. Okay, so now by looking at this, we can get different columns, different values. Now let's talk about the shape. One of the things that you can do, which can be really valuable, is actually looking at the shape of the data set. You want to see how many rows and columns you have without actually loading all the samples. And again, pandas has this functionality too, that shape. You remember NumPy? We use shape to return number of rows and columns. There we go. Like pandas has the same functionality as well. So when we do that, we see that the user data set has 943 rows and 5 columns. And you would see it here as reflected in this loaded zip file data frame. So the other beautiful thing that you can do is user.info. And what it does, it gives you the information about the specific data set. In this case, user. And let's see what we can have here. It gives you the total number of rows. If there's any missing value. So again, that's another important exploratory analysis, or like getting a little bit more scientific about analysis of the data set. In terms of images, for example, I keep going back to that same analogy. If a pixel is missing, for example, if you have a dead pixel, you have this image loaded, and you just usually do it in NumPy arrays, but you look for any missing value in there. You get in this way you can capture that. Or another example of that, we can have lists of patients, for example, sitting at this hospital with all the symptoms. And again, the symptoms can come in form of features, variable, columns inside your data set. You want to see if any of them is missing, because again, you want to do further analysis. You want to do, for example, visualization to clean the data, to make the data ready, for example, for neural network that you're going to design. So these are really important. And info is like, quickly give you an idea, okay, there's no missing value. The data type is of type integer 64. Gender is object. Object meaning that it's like a type string of or some form like that. And then there's another way to do that. Basically, there's another beautiful functionality called describe, which will give you the summary statistic of that table. So when I call user that describe, it says that I have two numerical columns inside my data frame. And again, I'll talk about what it means to have numerical columns. You see this user ID, age, and zip code. So inside them, we have data types of integer, right? Or like not integer, but numerical. It's in terms of numbers. They're in form of numbers, not a string, not object. So when you want to get summary statistic, the summary statistic includes mean, average, standard deviation, and so forth. Like you can quickly get that information from here. Hey, for those specific fields, they have this number of counts. So these are my two numerical columns. The mean is this, the standard deviation is this, minimum is this, maximum is this, 75th percentile is this, 25th percentile is this, 50th percentile is this. And then you can easily see, oh, okay, so the minimum age is 7, the maximum age is 73, 75th percentile reside kind of here. So I might have a skewed data set for age. You know, so like I might need to go and collect more data about like for age to account for that skewed distribution. Again, if you're in the field of biology and you want to do more statistical analysis on that. So that's how we do it. So now let's look at another data set, movie data set. So again, we loaded 3 different data sets. Movie, again, has all these values, all these columns. It talks about different genre of movies. We do the same thing, movie.shape, get the number of rows, get the number of columns. We see like we have 1,680, 21 columns, get the info. Summary statistic, movie.describe. We can even do EDA. So do you remember I told you about Matplotlib? So we basically loaded that, and now we want to get a histogram of the user's age, and that's all I need to do. So I basically loaded the user data set as a CSV file in pandas. I got access to age, and I said, okay, give me a histogram of that. And look what I see: minimum age, maximum age in this form, in form of histogram and number of counts. Correlation. If I want to do a really fast correlation plots, I want to see, again, what is correlation? The relationship between 2 different variables, right? If one variable goes up, does the other variable go up? If the one variable goes down, does the other variable goes down? Or it's the opposite? What's going on? So again, simply very fast, you can have a correlation table using this CORR parenthesis method. So again, I loaded this movie data set, and I want to apply this correlation. I want to get the correlation between different features, different columns of my movie data set, and that's what I get. It's kind of exhausting. I don't want to look at it in this way. So what would I do? I visualize it. How would I visualize it to make it more intuitive to read? Again, Seaborn. How do I do that? I import Seaborn as SNS. Again, this is the alias that I gave it. There's this heat map function in SNS Seaborn that gets this correlation that I just created and create this beautiful heat map for you. And you don't need to worry about these ones, these arguments. These are by default, some of the values. Again, you can read more about them in the basically document, but basically what they do is they style the heat map to represent it in different colors, etc., etc. So you don't need to worry about these ones. You can read more about them though. So again, seaborne heat map, correlation plots, and that's what you get. What does it show? The highest the correlation, like the more connection, these two basically the stronger relationship would exist between these two different variables. And how can we see that? Purple is the highest correlation, and you can see this diagonal. And this is one variable with itself. So we're going to ignore that, right? Because it doesn't make sense to compare one variable against itself. What we do is either this side of this rectangle or the upper side of the rectangle, because these both sides represent the same thing. So you only need one part of the puzzle, one part of this basically heat map. And if you see, for example, this one is kind of not high, but like a little bit below average. It's not as strong, but it's not also kind of low. It depends on, again, the use case. So children's and animations. So these two, for example, genres have 44% correlation. That's how we can actually identify that. Is it high enough? Is it strong enough? Again, that's the inference that you make. That's the decision that you make. No, it's not. It's not significant enough. I need a higher correlation to like make a conclusion about this too. But again, that's a beautiful way to quickly find the correlation. We have a third basically table, which is ratings. And that includes the ratings that different users have given to different genre. But if you look at this table, you see that we don't see the genre column here. We have the movie ID, user ID, and rating, and the timestamp. So again, we look to see how many rows and columns we have using shape. We get the info. We try to do basically use describe to get summary statistic. And again, I'm not going to go into all these questions because it would take some time. I try to make it actually a little bit more granular for scientists, but we don't have time, so you can go through it yourself. Just talk about the technical aspects of it. So, Farad, can you tell me how much time is left? Is it? I lost.
Yeah, it's
okay, go ahead.
Go ahead. Oh, sorry. Yeah, it's at noon now, but it's impossible to finish everything in 90 minutes. So you can keep going, and the hard limit we set is 12:30, including Q&A. So probably wrap it up in like 15-20 minutes.
Oh yeah, possible. Okay. Yeah, for sure.
Thank you.
Gotcha. Yeah, thank you so much. Yeah, that's perfect. So we have time. Let's actually talk about this one a little bit more. So again, you saw that we had different tables. We had movie.csv, ratings.csv, and user.csv with different columns in it. And what you also noticed, just to basically give you a summary, was this the function of the utility of these functions: head, describe, and info. These are really important, and these are really handy. We can use it quickly to get insights from the data. So now, when you organize your, for example, study, you come up with different hypotheses and questions, and you want to answer those using data. For example, how many movies belong to a particular genre? And again, this is a question that would you ask yourself to reach to a problem statement. Do you want to solve a problem statement? And again, you make a hypothesis. As part of that, you raise questions. As part of those questions, you try to come up with different tools to do your analysis. And that's the way you should think about it. That's what would separate you from like a good scientist, a mediocre scientist, to like someone who is brand new. So here, for example, we have a question: how many movies belong to a particular genre? And based on the previous inferences that we made, we'd seen earlier that a particular movie can have multiple genre. So let us investigate on this more. So we're gonna, again, look at this movie data set again. And as you see, we have all these different types of genres: action, adventure, animation, children, comedy, crime. And if you look, you see we have like either 0 or 1 inside of them. And what it entails is, for example, this genre, like this movie title, Toy Story, has this specific genre, animation. If it's 0, it means that we don't have that. Basically, this genre does not belong to this movie title. So animation, children, comedy. So the values are either 0 or 1. And again, I'm not going to get deep into why we represent the data like this, because it goes to basically machine learning or deep learning data preparation for basically predictions. But I just want you to know and understand that that's why, that's the meaning of these values. 1 means that comedy belongs to the specific movie title. 0 means it doesn't. So we have 2 values, binary values, 0 or 1. So now we're going to analyze the data set using pandas functions. So again, panda also has this function columns. And basically we say movie columns, and it would return different basically columns or features or variables that exist inside that data set. I can see somebody is asking, is it binary classification? It could be binary classification, or it could be multi-class classification. But the way we represent the data, because again, a machine learning model, basically, or a model that you would build, could see either 0 or 1. So again, you can shape it as a binary classification or multi-class classification. So this doesn't necessarily entail that this can be a binary classification. Again, for those who doesn't know about this, don't worry about this concept of binary classification or multi-class classification. These are the stuff that would yet to come, but for those people who have information. So again, we're talking about different columns, and that's how we can represent them. Let's see some other functionalities. So we can sum them. We can use actually mathematical operations on them. So you saw that movie was a pandas data frame. We use, again, this indexing, but here we say, okay, we had this data frame with different columns. Pick this genres column and sum the values inside them. So let's see what's going on, what's happening here. So again, movie, we had this table, we had all these genres, right? And we apply sum on top of them. So what we're doing, we're saying that sum all these values for these specific genres. So then we can see how many action genres we have in total, how many adventure genre we have in total, how many animation we have in total, because we're summing 1 or 0s, right? So that's what we're doing here. We're saying that, okay, create this list, genres. We have all these genres. And basically, inside the loaded data frame that I have, sum the values for those specific columns. So for action, sum the value. So I could represent this like this too. Let's look at it this way. Action. So let's see what we're saying here. We had this movie data frame. Inside movie data frame, we had this specific column called action, right? This is how I can access it in pandas data frame: square bracket and string key for that name, a specific column name, action. So if we go here again, look at this action, and then we apply the sum function, which basically sums the values inside this column, all these values and all the rows inside this column. That's what we're doing here. And again, we don't need to worry about these syntaxes and get overwhelmed by it. I just want you to expose you to the idea so you can get comfortable with the idea of data frames and how we have different operations that you can apply on top of it. The more you work with them, the more you get used to it. And of course, we have sort values. Do you remember for NumPy arrays, we had sorts, and we could sort them by basically ascending or descending. We have the same idea for data frames. So we have this function called sort values that you can apply on top of this data frame. For example, my data frame could be, again, users. And I have this specific function sort value. And I want to sort it by a specific, for example, column, values of a specific column. So I would actually mention it here. And I would say, is it ascending? Do I want it to be ascending or descending? The value of it could be Boolean. The default is true, meaning that this is ascending. Basically, source the values in an ascending order by default. If it's false, then it's going to be descending. And you don't need to worry about it for now. I don't want to confuse you guys with in place. But basically, whether you want to operate directly on the data frame or you want to have a copy of it, so the original data frame is not impacted. So again, you don't need to worry about it for now. So let's see how we can use it. So do you remember that movie in genres? And we applied the sum function and we got different sums, right? Different values. And now we have this. We want to sort these values based on ascending, ascending to descending. So that's how I do it. I say, okay, sum them and then sort the values based on ascending is false, meaning that we sort the values in descending order. And we have this from ascending to descending. So now let's talk about I won't talk about these ones. It might get a little bit overwhelming, which is like a little bit more material for you to cover. Let's talk about merges and loops inside the data frames. So now we talked about how we have three different data sets, right? We have movie, ratings, and user. So what if there's a piece of information in user's data set that we want to use inside the movie data set, right? For example, you notice that here we have in this movie data set, we have information about movie, we have movie ID, we have title and information about the genre. For in user, in ratings, we have information about user ID, movie ID, rating, but not the genre. So what if we want to use this ratings inside that movie.csv? What if we want to add this ratings that we have, right? This column. What if we want to add this column to the other table? How do we do that? So we know we have different data sets loaded. We know that we're doing analysis separately on those. How can we use one piece of information from this table on the other one? Add, for example, this column that exists here on a different, basically the different data set that I have. Well, we use something called merge. And pandas would allow you to do that really easily. All you need to have is a mutual or common column inside the two data sets. So you can see how we have movie ID both in ratings table, right? And in movies table. So we have movie ID both in movie.csv and rating.csv. So we can use that mutual key to merge this together. So we can also add the rating column to this data set. And how do we do that? Let's cover the concept of merge and what do we mean by that. I have like this graph for you guys. You can look at and get like an idea. Let's get there. Oh God, I think that. Okay, there we go. So again, so as we have already seen that the information regarding the rating is present in the rating data set. However, the genre columns are present in the movie data set. So we want to add them together. The only column connecting these two data sets is the movie ID. So we must have a mutual key in both data sets if you want to merge them together. We can merge both the data sets on the basis of common variable that is movie ID. So let's see how merges work. Pandas provide various functionalities to merge different tables on top of each other. For example, let's look at different types of joins. We have inner join, left join, and right join. Let's see the difference. Imagine we have this table, table number 1. This is our left table. We have index, ID, name, and age. We have right table. We have index, ID, subject, but there's no age. When we do inner join, basically what we do, we join together the mutual information that exists within the two tables. So here you can see we have all IDs in left table, all IDs in right table. So again, we recreate all the IDs, 1, 2, 3, 4, 5, but also we add age to it. So this is the table after merging. So now we have one single table with all the merged columns, some of it that didn't exist in here, some of them that didn't exist in here. And that's how we do it. pd.merge left. I'll show you an example in practice that would make more sense. And then we have the left join. So left join, it returns all records from the left table and the matched records from the right table. So here we have the left table. We have index, customer ID, and product. We have the right table. You see it's smaller. We have index, customer ID, and state. We don't have product. Also, some of the customer IDs is missing. We don't have all the customer IDs, but we're using left join. What do I mean? It means that I mean that this is my main table. So I want to keep everything that exists here, but I want to add all the columns that doesn't exist here, but exists here. So again, when I'm using left join, my left table is my main table. And I want to join all the columns that doesn't exist here, but exists here to my left table based on the customer IDs. Let's see how it works in practice. So I see pd.merge, do the left join, and do it on the customer ID, because that's the mutual column that I have in both tables, right? So you should have one mutual column. These two are mutual in both tables. So I can use that to merge in the columns that doesn't exist in here. And how do I want to do it? Left. So you specify how you want to do it using this keyword. If it's right, you would use right. If it's left, you would use left. And we'll cover what the right join means too. But then eventually I'll get this. So do you remember how I had product, but I didn't have state? Now I added the state to my main left table. But do you see how some of them is nan? Why do you think this is happening? Well, because we had customer ID 2, 4, 6. We didn't have customer ID 1, 3, etc., in this table. So again, we can only merge in the information that we have from these customer IDs. We didn't have information about the state for this customer ID from this table. So that's why it's NaN. But we can only merge in the information that exists in the state column and these customer IDs. So right join is the opposite of left join. It's exactly the same concept, but now rotate the tables. We have right table. This is my right table. This is my left table. Now my right table is my main table. So I would have it as a reference. I would merge in all the information from here to here. So now you can see this is like smaller, right? Because this is my main table and I have only the information about customer ID 2, 4, 6. That's what I would have too here, because this was my main table. You would see how I didn't have product column here. I'm sorry, this should be product. This is a typo, I should fix this. So one of them is state, this should be product. This should not be state. So here we have state, but we don't have product. But here we have product, and customer ID is mutual in both of them. I merge in information about product and some of these customer IDs that I have here, and there we go. I add this new column to this right table, new piece of information about the state. And then we have another one, which is full outer join, or outer or full join, which merges everything. So like I wouldn't have any reference. In this case, my left table or right table is not a reference. We take two tables and we merge everything. So you might end up with duplicates. And you often don't use this a lot. Just to give you an idea, you mostly use either left join, right join, or inner join, with a little bit bias towards like left join. Now let's see how it works in practice. Do you remember we had this movie that had information about the movie, basically genres and etc., etc. We take this table as I want to take it as my basically one of the table that I want to merge the new information onto. So I use this merge keyword or function in pandas, and I would say, okay, merge the ratings table to this movie table, and I want to merge them based on this movie ID, because this is the column that is mutual between these two tables. How do I want to do that? Using inner join. And boom, there we go. Now you would have ratings added to this movie data set. And you can give it a name. You remember we talked about variables, buckets, placeholders, Amazon package shipped to your place. So that's another Amazon package that now has information about this. And I can use head to print the top 5 rows. So what if I wanted to use left join? The same thing, left. That's the only thing that I wanted to change. So again, I take this movie, in this case, as my main movie. Main table, which would be my left table. And I would say merging all the information that I have in ratings that doesn't exist here based on the movie ID, because this is the mutual column that exists between those two. How do I want to do that? Left join. What did left join do? This. I think we're almost done. I'm just going to cover the loops, like one, basically you loops in data frames, and then I think we're there. So again, when we use data frames, pandas data frames, again, when I talk about data frames, I'm talking about that beautiful spreadsheet, right? Columns and rows. Often we can use for loops to go through different values of a column. So let's see how that can happen. So again, do you remember inside my genre, we had this different genres? I'm sorry, inside my, so let me actually, I think I had another example which was easier. Let's go here. Let's start with this simpler example, not to make it complicated for you guys. Let's build a new data frame. So I would call it DF example 2. And as you remember, if you want to create a data frame from the scratch, you would specify, you would use basically dictionaries, right? So, and that's how you do it. Import pandas as PD. PD was that alias. And then you use data frame. And then this was your record. So now inside my data frame, I have this key, number of legs, and values for this specific key, 4 and 2. Number of wings, this is another key and values for that, 0 and 2. And I want to use this indices, dog and hawk. So now you build this beautiful table. The indices are this, dog and hawk, and these are the columns. So again, dog has 4 number of legs, right? Hawk has 2 number of legs. Dog has 0 number of wings. Hawk has 2 wings. That's how we can represent this data in form of this data frame. So now I want to loop through it, loop through this, the values and keys, like columns and rows, and print different values. How would I be able to do that? One of them using for loop. So we use for index, and content of that index in df example 2.iter items. So now you see something new that you hadn't seen before, iter items. So again, pandas data frame would give you this functionality, a function called iter items. And again, as the name entails, it iterates over the items inside your pandas data frame. So let's see what we would get if we print the values. We're printing the index and the contents for each time we loop through different values inside this data frame. So the first time we get number of legs. So we get this column. So this is my first item. And then I get 4 and 2. There we go. The second one is this. This is another item. Number of wings, I get 0 and 2. So iter items basically loop through different columns of your data frame, of your spreadsheet again. And using a for loop, we can do this. So again, for index and contents in df example 2, this one, the columns of it, just print different values of it. Now we have something similar for rows. Now, instead of columns, we want to iterate on rows. How do I do that? Well, the same concept, but now instead of iter items, I use iter rows. So now I would say for rows inside this data frame example 2, iter rows, print the row. And let's see what I would get. The first row is this, right? Dog, number of leg 4, number of wings 0. There we go. That's my first row. What is the second row? Hog, number of legs 2, number of wings 2. We have something like this for tuples. So again, data frame, intertuples, interrows, intertuples, and let's see how it works. So we create the same data frame, df example 2, nothing has changed. But let's see the difference between this one and the iter rows and iter items. If we use iter tuples, what it returns, again, we return this format of data. So it basically returns the data type, which is pandas, and it says, okay, number of legs for this row was 4, number of things was 0. So it returns a tuple of these two values of this row. Values of this row in this format. So you would see when you use this two, the format that is returned is kind of different. So in here, not only you get this, for example, data type, integer, etc., but like more information, but also you would basically get the column, the basically name of the rows, for example, the indices, dog and hog. But when you use intertuple, you don't get these names of the indices. You can just get the values of the rows. And this is pretty faster in terms of computation. Again, if you're obsessed with computation and want to loop through different values of data frames, then intertuple for looping through different rows is faster and more computationally efficient. I think this is it, guys.
Yeah. Perfect. Thank you so much.
My pleasure.
Yeah, that was a really informative session. You covered all the scientific programming basics for NumPy and Pandas, and I do like to encourage everyone to read the documentation if you're curious about anything, and that's always the way to go, and Google stuff. This is a really good initialization point, but the rest you're on your own. And the documentation, especially for Seaborn and NumPy, there are so many good examples just from the documentation themselves, and you can just try out examples that way too. Cool. Anything else for how you would like to add?
Yeah, I just want to add that we have a Discord channel. That's a really great environment to go ask your question. We have mentors that ask your question. Also, feel free to engage in conversation with other members. Please, that's really peer learning is a great opportunity to learn and also share what you know with others. I also just want to thank Sam for the great presentation. It was really informative and covered the most important concept that we need perhaps for our future lectures. Thank you.
Thank you so much. And Luca, is there anything else you would like to add?
No, that was a super informative. Thank you so much for taking the time. Thank you for all the participants that stayed until the end, and stay tuned for next week.
Perfect. And just like to remind everyone, the official opening ceremony of McMedHacks this year will start on this Saturday, which is June 11th. Luke and I will give an overview of the entire program details in terms of the future workshops and seminar series, as well as we'll talk about some burning questions like how we're going to go ahead with the certificates and attendance and so on. So thank you very much for coming. It's great to see you all. See you next time.
Thank you, guys.